Good afternoon, people. I hope that we all had a chance to enjoy the lunch, the comida mineira, to enjoy the friends, walk around here in the campus. So it's a very pleasant place for all of us. Now, returning to our schedule, I would like to invite our great long-term partner, Bob Hughes, to offer his talk here. Bob, please. Here, the left, and here, go forward.
Let's forward.
Yes.
Coração?
Ele mandou só em PDF, ele falou que não tinha PowerPoint.
Ctrl L normalmente põe tela inteira.
Living and learning.
Okay. First, thanks to Marcos and his team for inviting me and all of you here. It's been a wonderful experience. I want to also thank my earlier sponsors here. I never would have been able to visit Brazil as many times as I can without that support. When I first thought about coming to Brazil, I always thought of the Amazon with tremendous biodiversity and all kinds of amazing species and whatnot. But if I can get this right. But I soon learned that there are many, many different kinds of biomes and ecosystems and stream types. Hugely diverse country. And more importantly, and I've said this many times to many of you, I came first for the biology, but really it's the people that brings me back. So this is maybe the most important slide. In 2001, Phil got an email from a gentleman in Usina in Rio Grande do Sul. He wanted to have Phil come and give a talk about physical habitat structure, and it's important to biology. And I think if I remember the story right, he asked Phil if he knew anybody that knew something about IBI. And Phil says, well, there's a guy next door that actually knows a lot about it. So he asked me if I'd be willing to go. And in 2001, Phil and I got on a plane and flew all the way to South America. And that changed my life in many ways. I met two people, Gerson Araújo and a strange man named Carlos Alves. And from them, I met this whole set of people. Many of you are listed there. And I want to emphasize that congresses like these are what happens. Now, that's very, very important. And the key thing here is connectivity. In biology, connectivity is incredibly important. If you don't connect ecosystems, they fall apart. It's the same thing. It's the same message, I think, that we heard from Juliana yesterday. So those are if you don't know Carlos, Garrison. But when I first met them, they took me to these streams. Oh my God. Yes. That's not my idea of biodiversity. Remember, Carlos?
Begin with this.
Yeah. Fantastic. But since then, with all the help of all of you and other students, we've published something on the order of, what is it, 88 papers that are in press or published. That's not me, that's you and your colleagues. So this is the teamwork again. Includes a book chapters, various kinds of topics from bioassessment and biodiversity threats. And they were published in pretty good journals, most of them in ecological indicators with an impact factor of 5, one in science with a impact factor of 45 essentially. The journal that I edit, Water Biology and Security, that's a bias, that's a plug. If you want to get a paper in our journal, talk to me. We want papers from Brazil and Uruguay even. So our first work was in Mount Atlantic streams with colleagues from the Federal University of Rio de Janeiro and the Federal Rural University of Rio de Janeiro. I don't know if any of you know those folks, probably some. Typical Mount Atlantic streams, very high slopes, big substrates, beautiful systems, unless the water is high, and then they're very dangerous to be in. We don't sample these in the wet season. You die. We only sampled them once. Published a large number of papers, just some of them listed there. The key comments. We're trying to figure out biomonitoring. So in the US, we found that 40 channel which was sufficient to get you pretty good repeatable measures of physical habitat structure, maximum vertebrates and fish. Wow, that was insufficient in most cases, except for the very common species. It's similar to what Paulo said this morning. You can get the common ones with that effort, but you'll probably never get the rare. So we want to emphasize that fish species richness, diversity, and abundance and biomass are poor metrics for NMIs. They're too noisy. They increase with disturbance until they get very bad and they go down. So be very cautious about those measures. They're important, but they give you some somewhat incorrect information. Local variables explain more variability in fish taxonomic and functional assembly structure than catchment variables. Local is more important than catchment for fish, and I think it for bugs too. And then in 2003, I met these crazy guys. You heard from Paulo this morning, and Marcos, you all know. If you don't, you're unfortunate. I think that was in 2003 or thereabouts. And they invited me down and we talked about this kind of stuff. And then, more importantly, maybe, I met a lot of their graduate students. Some of them are here. I think Diego's here. This Diego is here. Martin's here. And if you look at Diego, well, he looks different now. Better, more handsome. Diego and I worked in the field together. I spoke more Portuguese. Diego spoke more English, and somehow we collected very good data. We thought it was good data. It got published. Yeah. With Phil, we gave a field course in maybe 2007, with the Geocicle. I learned something there, of course. And that developed into the CIMIGI project. And again, CIMIGI was a huge factor in getting us. And then, amazingly, Marcos organized a trip to Corvallis. I think it was cold for some of you people. And rainy, cold rain. But they found that the cerveza was good. And so, I don't know. I think it's fun to look at how people look, whatever that was a few years earlier. Another thing that always impresses Phil and I when we do our field work in Brazil is we drive these wonderful roads that you have, and for some reason we find these camiones that are on the side or upside down. I don't know what's wrong with them. It's perfectly good. What happens? It's not unusual, right, Phil?
We saw it every time at least.
Last fall, we saw two. Anyway,
No, I didn't see it.
yeah, I have to go back to Kawasaki.
Yeah, that's
A biological question, though, is what are the effects of the spills from trucks, especially on roads or near bridges? They're carrying things that could be toxic, and roads act as tributaries to carry contaminants to waters. Anyway, it's another graduate student project. Cerrado streams, sort of intermediate between Mount Atlantic streams and Amazonas streams, rockier, steeper. Again, lots of publications with this group. Key points. Macroinvertebrate taxonomic and functional beta diversities markedly exceed their alpha diversities. Paulo talked about that this morning for fish. And that's where the diversity lies. And the key thing there is you don't protect biodiversity by focusing on a single site. You have to look at large numbers of sites that are connected. Agriculture, pasture, and excess fine sediments produce the greatest risk for poor macroinvertebrate MMI scores in Cerrado streams. So, pretty simple stuff, land use and fine sediments. We've been talking about fine sediments yesterday, the importance of them carrying through the systems. It's not exotic contaminants and things like that, just dirt. Lama, araya. Then I worked some with Gilmar Santos. I don't know if Barbara's still here somewhere. She was back there hiding. We're still working on a paper together. I wanted to go back. It's important to know with Gilmar that you always have this liquid material around. And even when you're in the field, he's taught his graduate students the importance of cerveza. And the focus there was mostly on reservoirs, fish in reservoirs. These are some examples of the papers. Key things, benthic macroinvertebrates were responsive to anthropogenic disturbance levels between two reservoirs, but not the site scale water quality and physical habitat. So what was happening at the site was not connected with that whole system. Something else is driving it other than what's happening at the site, I think. Importantly, reservoir, riverine, and lacustrine zones differ in fish species richness, diversity, and blending. A reservoir is not a reservoir, it's at least two reservoirs. The lacustrine systems differ markedly from the riverine systems. It's like a difference between a river and a lake. I think you found that in Furnas as well. In 2010, I was fortunate to have a Fulbright grant to spend 6 weeks in Brazil, or 6 months in Brazil, really costed by marriage. And in Paulo's lab, we heard Paulo this morning, but it's a very serious bunch of researchers. They are always in deep philosophical conversations, as you can see here, especially here in Thessaloniki. The focus there is a lot on physical habitat structure and fish sampling. These are bigger fishes than you get, Franco. Some examples of some of the publications. Some key points. Only 709 kilometers, 9% of the stream length in 4 Cerrado hydrologic units were in good condition based on fish MMI scores. Only 9%. So most of them were not in very good condition. Catchment land use explained little of the fish assembly structure. Again, similar to the reservoirs, it's something occurring more at the site level. Then, in most hydrologic units, 100-meter long sites were sufficient to collect about 90% of the fish species. This is similar to what we found in Mid-Atlantic streams. Interesting enough. Again, we are not getting the rare species. And then, in that same year, I was fortunate to be able to do some work in the Amazonas streams with this group, some of whom you might recognize. After a day in the field, it looked like this. I learned about llama. There was Paulo 14 years ago. Rafael, Leandro was younger then. And maybe wiser in some ways. Somewhat typical Amazonas trees, very low gradient. I've never seen in North America trees growing in streams. It happens in Florida, I'm sure of that, but I've never seen that. We got a lot of help from the local people, especially the children. They were really helpful. They were very fast and enthusiastic. And the local people were helpful to help us get to the stream. Many times they would offer coffee or fruit. They were poor people, but everything they had, they shared with us. Wonderful, very wonderful. My clothes were washed here every week. Usually they came smelling quite badly, I think. But they came back wonderful. It's amazing. It's magic. The last day we had a wonderful meal of tambaqui and arapaima. Maybe my two favorite dishes in Brazil, except with Hanada, we had some really wonderful, what's that? Mushrooms. In Portuguese? Cogumelos. Cogumelos. Some of the publications from that work. Lots of key points here. Aquatic insect and fish metrics calibrated for natural gradients produce better NMI performance. So you had to calibrate them for gradient, for natural changes in slope and whatnot. In-stream habitat predictors explain more variability in fish assemblages than riparian or catchment variables. Again, a similar story to what we found in Mad Atlantica and Cerrado streams. Channel shading was strongly and positively rated to Zygoptera species, but negatively to Anisoptera. That was, to me, a remarkable thing. I thought all odonates behave the same, but Leandro and his students have shown that many times that they occur totally different, almost totally. There's some exceptions, of course. We did some Titan modeling, and we found that sensitive fish species were lost at little as 1 to 6% of forest loss at catchment and riparian extent. So 1% of deforestation in the catchment resulted in the loss of some sensitive fish species. And Paula was talking there about rare species. These are rare and sensitive. A little bit of change. Similar, sensitive macroinvertebrate taxa were lost at 1 to 11% of forest loss at catchment and riparian extents. Now, the interesting thing to me is that both of these examples, the catchment had a bigger effect than the riparian zone, which I would never have expected. Of course, Diego knows that. More recently, I was invited to have another Fulbright grant with a couple of these characters. I don't know if you folks know Rafael in his early years. I taught a course there on biomonitoring and journal publications, gave some lectures, a wonderful group. Raisa took my class in publishing in journal and got me honest. I think she encouraged all the students with a bottle of cachaça to attend. And it worked. Another thing I really liked about Belém, as usual, was the people. I met people in different families and shared meals and whatnot. So, a great time. Again, as always, journal publications. Major conclusions. Fixed count is better than fixed area subsampling for measuring taxa richness of macroinvertebrates. So a certain number of individuals is the most efficient way to do that. Cost-effective diversity estimate should sample multiple microhabitat types and stream types. If you only go out to a few places, take a few samples, you're going to miss a lot of the important diversity. Again, the same thing that Paula was saying this morning about beta diversity. It occurs at multiple scales. Working with Gilberto, chronic disturbances are as harmful to fishes as the acute effects of a tailings dam rupture. So in the Dose, you had a massive tailings dam failure, wiped out things, fishes anyway, for a while. But it wasn't as big an impact as the chronic disturbance in that tidal basin, the land use. Stream fragmentation by tailings dams, small tailings dams, sometimes no bigger than this room, alters upstream fish assemblage structure. So a very small barrier changes the fish assemblage above that barrier. And next, in the same year, I worked with Bianca Terra in Paraíba, published a paper. The title is exactly the result. Fish and macroinvertebrates respond differently to drying and tropical non-perennial streams. So the way the fish respond to drought is different than the way the macroinvertebrates respond to drought. Should be no surprise. That's why we sample both assemblies. One reason. More recently, working with Hanada, these papers. Major conclusion, differentiating natural variability from anthropogenic impacts is a major challenge in creating and applying NMIs. They have to calibrate for natural gradients. Could be size, it could be slope, it could be some kind of substrate. In building NMIs, reference condition criteria had the major effect on NMI response rate. So do not underestimate the importance of good reference sites, good reference conditions. That provides the benchmark for all those comparisons. And lately I've been working with Jason Moy, a couple papers. I'm looking at Jason. Key points. Human pressure reduced stream habitat diversity and the richness of an abundance of fish and insects. Probably no surprise, but this one I think is. Stream habitat diversity mitigates, reduces or lessens the negative effects of human pressures on fish and insect assimilation. So there's still hope. I mean, if you have decent riparian condition, you can protect a lot of the biodiversity in these systems. It will not be the same, but it'll be better than it would be. Even in grassland streams, I think. Lately, I've been trying to work with this gentleman. Hello. Is he here? Where is he? Hiding in the back someplace. Yeah. On a big project. Gilberto's on that. Lately working with the young lady there. Again, working with the state agencies. Working with Diego and Tama on some mine spill problems, a big issue. And this is a neat publication from Diego from 10 years ago. The key thing here is all of these drive the habitat, which in turn drives what happens in the biota. But these seem to be more important. These seem to have more effect here, but what happens here is driven by what happens up there. So it has to, you have to look at all those levels to understand it. At least I think so. And Diego agrees, right? I want to thank my patient family. A quote from one of my favorite authors, Norman MacLean. Eventually, all things merge into one thing, and the river runs through it. So the key thing why I became an aquatic scientist is that aquatic systems integrate everything that happens in the drainage and the area around. So we can look at them and understand a lot about what conditions are occurring. So, thank you.
You see the picture of fully Brazilian animals and the capybara.
Which one is which?
One is you.
Some of you were here when I asked difficult questions of other speakers, so I encourage you to ask questions that are difficult. And if you cannot ask them in English, ask them in Portuguese and Phil will translate. No, seriously, please.
O Paulo está querendo, então, que qualquer um pergunte, principalmente perguntas difíceis, que se você não puder responder, o Phil vai traduzir. Bom, em nome de toda a equipe, nós emocionados. We are emotional to thank you very much for coming and to be with us for this 20 years or more. You changed our lives also. You know that. Thing is, everybody wants to make any question. It's okay.
Well, Bob, that's a very beautiful story, and I'm happy you merged with us. And Toby sends greetings to you from WhatsApp here. And it's really interesting to see everything put together. And I got very curious that you mentioned in one of your slides that the chronic impacts are as severe as the acute ones. This is something, of course, I'm studying at the moment. And I would like to hear from you which one you think that prevails if, for example, chronic impacts are there for a long time. The situations that we have here, what do you think are the effects of acute impacts in systems that were so severely punctured over time for lack of policy and mistreated by people?
Good question, Babam. I think, as usual, it depends. It depends on how serious the acute impact was or is, and how serious the chronic impacts are. But I think we tend, as a species, to get more excited by acute things. It's so dramatic, but it's those slow things that are killing us. I'll get very personal. Two major diseases kill humans: heart disease and cancer. They are both very chronic. We usually don't die of a heart attack just because we're speaking in English. We die of a heart attack because we do not exercise enough, we don't eat right. We chose our parents wrong, don't have good genetics. It's slow things that run in it. But thinking of the mining disasters you have here, and the Dose, that's where that example came from. The big changes seem to have been the chronic disturbance of the whole landscape for centuries. The fish, they left when the spill came, they went into the tributaries, they came back soon after, within months. So, they're used to it. They're all used to changes.
So, as Brazil is a continent-wide country like the United States is, and we have different diversity, but in terms of diversity of environments, we are different, but we have many different ecoregions, for example, in our countries, but our biological diversity is much higher. The IBIs were developed there in the temperate climate, and we are applying here. So what will be some lesson that you learned about working in so different countries, even if they are similar or in ecoregion numbers or extension, but biological diversity is too much different.
Are you referring to IBIs and MLIs, or just diversity in general?
The way to see this, like measure it.
I think some of the metrics are very similar based on Jim Carr's original ideas. Probably somebody should translate. I forget all of his. One was species richness or tax emissions. That's still an important measure, but do not include non-native species with native species when you're making that estimate. And break species richness into groups of species, insectivores, omnivores, herbivores, for fish. And the same thing goes for macroinvertebrates and probably for algae as well. That's what I asked Thais about structure. I mean, what groups can you put those in? Well, recently, we're finding that functional metrics are very useful, what the organism does. And that's sometimes more sensitive than the structural or taxonomic thing. So, and calibrating is awesome. Don't ask me a statistical question now.
During Paulo's lecture, thank you. You comment to him that both macroinvertebrates assemblies and fish assemblies have different sensitivities, and so I'd like to ask you, your experience in working with both groups, to which disturbance or conditions you would advise to use one metrics for one assembly or the other?
I think it's always useful to use both because they see the world differently. I think fish, because they have to migrate, they have to move. Even small fish move. We have a small fish called a cod. We don't even have that family. And for many years, people thought they only occupied 1 square meter. So, but they're individuals of that family that go 2 or 3 kilometers up rivers. Tiny fish up steep channels. So if you put a road in between or block it somehow with a dam, they can't move. And then if you put hundreds of roads between where they begin, where they'd like to go, they're decimated. So the fish are very good at assessing those barriers, whereas insects can fly over them. But not all macroinvertebrates are insects. So some of them cannot move. They also interact with like barriers. I like your paper, your Zeta paper. I didn't put that up there because it's not published yet, but Madden's found that you have sensitive species that are affected more by local disturbances, and common species are affected more by the widespread disturbances. So these are macroinvertebrates. So it's the kind of thing happens. So. Attention? No, not really down.
Not difficult question, but no problem. Thank you very, very much. You are much more than a partner in our papers. You are a really teacher. You teach us how to be really scientists, and it's amazing to be a friend of you. But some tips, some tips on the next steps. What do you think about we should focus for the aquatic science in Brazil? Maybe temporal dynamics, maybe large rivers, urban ecosystems. What do you think we should focus for the next 10 years?
There's so many things. One of my loves is rivers, so I'm biased by rivers. If I have free time, I'm either on a big river or I'm skiing. If I have, and a mountain is just a big river. It's ice and snow. It's flowing. It just flows. So anyway, that's philosophy. I think the key thing that I see both in the Haas project, Samiki project, Furnas project, is getting large groups of people together and answering big important questions across large areas. And that's a problem with a lot of graduate student studies. You have 2 years, a little bit of money, you can only sample 2 sites. And I don't think we get the answers that we need. I mean, most of our studies are local in short time, and most of our big problems are over centuries and over planets. So somehow we have to bridge that gap. That's what we're doing with ENAP and NARS projects in the US. It's a smaller scale, smaller extent here in Brazil with the hydrologic unit study, with the house studies. So I really want to suggest, and the only way you can do that is collaborating, working together. But I think the work that you're doing on the dosing, I think some of the work that in some of these mine-scale rivers is really important because they're harder to study, they're more dangerous to study, they're more difficult to study. But Hanada's doing on a river is more complex. So we have to find a way to study rivers. And most people that are not scientists are more concerned about rivers. They see them, they live on them, than they are in small cabeceros. So we have to go where the people are. That's probably 100 years, not 10 years. But I think what you're doing is one of the key things. Yeah.
Thank you. Anybody else?
Yeah.
It's compromise. Yeah. And Karen, yeah, that's an easy one. I love it.
What we need in next kind of. Bruno largou.
Não, já fala aí.
Quem é o próximo? Oh. I don't know. It's the order. No. Now we, in the name of the coordination, we invite Phil Kaufman to make a talk for us. And I.
Great.
Well, I'll have to get back at these guys. Some of you who know me from before know that I worked as a musician. And so what these guys did is they booked me after a rock star, and I'm only a small regular guy. So anyway, I'm going back to more or less lofty, more of a narrow topic. But it is a spiritual topic. It's about physical habitat. Probably the most important thing, of course, about rivers and streams and reservoirs. You're supposed to laugh at that point. So when I first started, this is about, say, 1990, the EPA administrator asked me a question, and they said, well, you like this physical habitat stuff. Why do we want to sample it in streams? And some at that time, and still today, is something that's been neglected continentally or in most countries. We suspected major impacts, and as I mentioned in a couple of my comments, things like incision can take centuries or millennia to recover. And habitat, even though it's of course important, it's in its own right or it's of itself, it's also important for understanding the biota. And now in United States and Brazil and in Europe, there are suitable quick but quantitative methods that are available for looking at, like Bob's saying, at regional and continental levels. So to address the EPA administrator question, we put together back in the 90s a workshop of biologists, ecologists, geographers, chemists, and geomorphologists, hydraulics people, and they were from various parts of North America. And we were asking them, well, what are the important dimensions of physical structure in aquatic habitats? And I gotta make sure I don't change things. So channel dimensions, of course, gradient, these are things we came up with in that workshop. Flow regime, bed substrate. It was a group about this size. In-stream cover, that's habitat structural heterogeneity, riparian vegetation, structure and cover, human disturbances, and something about channel riparian interaction. And again, the EPA administrator came back to me and said, well, okay, yeah, but how do you measure those things? Those are good ideas or dimensions of habitat. This, by the way, is not the EPA administrator. So what do we measure? And then we put ourselves together over the next probably 6-7 years, a series of pilot studies, and it kind of reminds me of what we were doing in UFMG over during when the four, what is it, the Tres Marias, Volta Grande, those. And we have lots, and I have some specific slides on results, but we did a lot of pilot studies to see what's the appropriate scale and resolution of measurements, what's the critical time period we should measure things in, and what is that, should we go after all those attributes that the workshop identified? And if we did that, can we identify and put together an explicit plot design? And by plot, I mean on the stream site. Is there a way we can make it so that you and he and me and someone else will all get the same kind of measurements if they do it at the same place? And for this, we also favored quantification over judgment. And I'll have to qualify, whoops, that's the same kind of word, isn't it? I'll have to qualify that a little bit in that we don't want to send our field crews out to say this is good, this is poor, but we want them to either make measurements and we determine from our studies what is good and fair and poor, or we estimate something that could otherwise be measured, like cover. Like we can't spend a week at a site, so we spend one crew half a day, 2 people half a day, and that was kind of our marching orders for this. So rapid, efficient sampling is necessary if we want to get across a continent or across a basin. So I won't go into this in a giant amount of detail. We have, actually a lot of you are very familiar with it, I know, but we have a reach that is 40 times as long as it is wide, or a minimum of 150 meters, or a maximum of 4,000 meters. And on that reach are a series of cross sections where we measured substrate and width and those kinds of things. And also at those cross sections are plots in the riparian and in the channel where we measure other things. Something similar for potable streams, but I'll concentrate on the wadeable streams, otherwise we'll be here too long. So at a wadeable site, we have a long profile of the thaw wake depth, superficial fines, and habitat class like pool, riffle, glide, that kind of thing. Width and substrate, 11 different cross sections where we measure these things. And then in the riparian, we also measure these. And the whole reach, we do some other things like, was there a giant flood? Was there a debris torrent, a lahar? Or we also look at the constraint from a giant perspective, like is the stream in a wide valley, that kind of thing. And then again, this is my daughter's picture. So she asked me, oops. This is of course me, and this is her. And I said, well, yeah, but what do you do with all those measurements that you collect? Do you report to the EPA administrator, oh, the width was 27.3 meters, and what does that mean? What does that mean from a standpoint of stream health? Well, first of all, these are the kinds of things, the basic tools or the building blocks that we build an index or an indicator of stream health from, so means and standard deviations, percentage fines, that kind of thing. So basically just manipulating those numbers, but again, still that's data, but it's not information about what a stream really is like. Now, we couldn't do in the national assessments, they said, well, pick 4. And of course, I wanted 8. And they said, pick 4 characteristics of streams that we will put in the national assessment. And so we did this excess fine sediments. We kind of looked at what are probably expected to be the major influences on biota and the major connections to human activity. In-stream habitat cover complexity, wood, undercut banks, those kinds of things, riparian vegetation, cover and structure, and then the presence of humans. There are a couple of different ones that if we have time, I'll go into that we're trying to develop. So the first one, this is my son here. No, that's so the first one is stream bed excess fine sediments, and those of you who work in streams or take engineering classes know that you won't find boulders in a flat stream, and it's really difficult to find silt and fines in a stream that's this steep. So what we do is we scale that, the sediment fines that we have, or the sediment diameter, by the ability of the stream, the power of the stream to move that sediment. I forgot my water. I need to. Yes.
Do you want to refill it or not?
So, and those of you who have engineering, I was actually talking about shear stress. And it's affected by the landscape, like if you're the slope of the stream, the size of the stream, so depth times the slope of the stream is basically most of that information. But things like wood, pools, all those things will tend to reduce the shear stress and allow sediments to remain in a stream that otherwise could move them out. So the first index that we made was the index of relative bed stability, where on the x-axis this is the size of diameter that the stream can move during the bank flow, and this is the size of the diameter that we see in the stream. And if they were in equilibrium, and if the sediment that's in the stream keeps getting replenished and the stream moves all the smaller stuff out, then what we're left with is most of the sediment in streams would be like this. Well, as it turns out, if you get a lot of erosion, there's a lot of fine material that ends up so that in the stream, so the observed diameter is much smaller than you would expect it to be based on this. And the only way that can continue to be the case is if you move it out every time there's a flood and you replenish it again. Another way of looking at this is the ratio itself. And what we find is that as you increase, this is something like Rafael Legero's IDI. And this is the ratio of observed over critical diameter, the diameter you can move. And so it goes down in Oregon and Washington, about 3 orders of magnitude smaller than you would expect. So these streams have a lot of fines in them, even though their power is quite high. So that means that the sediment supply is high, and those are as the high sediment supply is associated with the riparian and basin disturbance. And one could ask, well, who cares? You know, and so we asked the bugs and the fish whether they cared about this. And the answer from this standpoint is the fish IBI generally goes up as relative bed stability goes towards zero, which means that those blue lines in the other graph, it starts going down when you get hyper stable or very stable streams. And those that are X's here have more than 20% bedrock. So the bedrock is left when you have overpowered stream and not enough sediment. And bugs, kind of the same thing, in that the bug, in this case, EPT, mayfly, caddisfly, mayfly, stonefly, caddisfly, that this goes up. Some streams maybe that have bedrock are too stable. Now, the second of those dimensions that I was asked to provide indexes of condition, good, fair, and poor, for the EPA's or the US assessments, is habitat, in-stream habitat cover complexity. And those of you who've seen a lot of the talks in here used that kind of an index where you're looking at all these kinds of things, and there's different kinds of ways you could approach it. You could have, what's the total cover of all those things, or how many types of those are there? So this is a very recent paper that Jason Moy and me and Franco, Bob, Luisa are all on this paper. And generally what we're seeing is that fish and bugs really like the habitat diversity. So they're whoa, something happened. I don't know why this is not showing this, but this is richness of bugs, richness of fish. And this is basically saying what Bob's conclusion slide was, is that human pressure decreases the diversity of bugs and fish. In this case, this is richness of both exotic or non-natives and natives. So that's going along with human activity. Now, the high, medium, and low habitat diversity is mediating or mitigating the effects of human disturbance. Another of these measures is riparian cover and structure, and really we look at this in quite a simple way, as looking at canopy, mid-layer, and ground cover. And relating this back to Jason, this is for the whole US, what we're finding is that habitat diversity is decreased, and I'll make a simpler version of it's decreased by human pressure, but riparian cover increases it. Human pressure decreases riparian cover, and the end is that fish and bugs both like the diversity of habitat cover. Human activity decreases riparian cover and structure, and that in turn decreases habitat heterogeneity. So there's both direct and indirect controls on the macroinvertebrates and fish. This is I will make a very much simpler version of this, is that Amy Fergus and others looked at the same kind of thing, and we were in a very much more localized, focused area. And I won't go into this, but a summary of this is showing that sand and fines this is the total standardized effects, the reduction in macroinvertebrate MMI, that excess sand and fines is decreasing this habitat richness, increases the MMI. This is across the US. I'm sorry, the arid West US. And forest riparian and site riparian cover is a positive effect. Agriculture, and a couple of agriculture and non-agriculture is a negative effect. And flow alteration, this is flow alteration would be a reduction in flow and then this is positive flow. So if we have abundant flow in the summer, it's a good thing for those assemblages. So again, the question for me was not to say, what is the, what are these things controlled by, but EPA wanted to have, well, tell me it's, okay, I know that riparian affects bugs, but can you tell me what is good and fair and poor? And that really is not a very easy question to answer, as a lot of you suspect. And in a nutshell, and Bob mentioned the importance of choosing minimally disturbed reference sites and a lot of times you won't have them, and I'll show you how we've dealt with that. So we express these habitat measures like bed stability or percent fines or habitat heterogeneity as a measure just like you would with an MMI, an observed habitat measure, and an expected measure based on the landscape and the location. So then we set the condition criteria based on the reference distribution of the O over E values. That's different than the biologists generally do. I would encourage them actually to do what we do in that, but another story. So Bob kind of alluded to this as well, is that how successful you are in saying something is good, fair, or poor depends on, one thing is that here's the distribution in, say, in the region, this one on the left. Here's the distribution in reference sites. So the more different this is, and also the more accurately you can portray it, the more you have the ability to discern. And we say that something is poor if it's below the 5th percentile, and it's good if it's above the 25th percentile of these reference sites. So in a perfect world, you would be able to predict exactly what a value of something like cover would be based on all the things, the characteristics of a whole, let's say 100 sites of reference sites. The reality is you can't do that. And even if you could, they vary on a seasonal basis or between years. So the goal though is to reduce the variance of this prediction of E. So it's basically saying model your expected condition, your reference condition as well as you can, and try to make sure that it is something that's distinguishing between poor and good site, or disturbed and non-disturbed sites. So what we did in the US for all these habitat characteristics, we would model both geoclimatic, what we call natural variables, and then anthropogenic variables. And we would try and avoid things like this, where air temperature, annual precipitation, those are things that could change with climate. And so if we had a choice, and we had a choice between elevation or latitude and one of the climatic variables, we would choose something more like this. Then these tended to be like what I had done is in detail, we did all the possible variables and chose a set that we would then use. So we're parsing it down. So for relative bed stability, the things that came out, we ended up needing to address these or model them separately for ecoregions. We also modeled them separately for weightable versus non-weightable streams. Latitude was important for bed stability, and basin area was important. And you can see these are, latitude is one of the large determinant of of vegetation and climate in the North America, channel slope and basin area. Then for human activities, we ended up having a large variety, and they differed among ecoregions depending on what type of land uses and what the ecoregional characteristics were. So for in-stream habitat complexity, a little bit different, but still it's depending on ecoregion, again, latitude and longitude, elevation, basin area, channel slope, and channel wetted width. And that's not everyone. What we ended up usually was 2 or 3 of geoclimatic variables and 2 or 3 of these. So we're not throwing we throw all these variables in the potential, but we parse it down to those that have they have to have a mechanistic explanation for being in the model, and then you also want them to be less than, like if you have 100 sites, you want much less than 10 variables. So to take for every degree of freedom, you want 10 sample size of 10. Riparian vegetation complexity, very similar to that. So I'll just illustrate with one case. This is again the relative bed stability. So excess fines. If it's low, that means there's excess fines. And then I didn't know what happened here. This is low, medium, and high human disturbance footprint. So it's not good, fair, poor. It's reference sites, medium sites, and highly disturbed sites. And if we just took relative bed stability on its own, there is a relationship, but we don't know whether it's because the disturbed sites are found in a certain lithology and the references are in another. The second thing we did was we just set the reference sites to the median of the ecoregion and said that's the expectation. In a third type of model, we only used natural geophysical or geoclimatic variables. In another model, we used geoclimatic variables plus human disturbance variables. And remember I said that one of the goals is reduce the variance of the reference sites. And you can see that the smallest variance in this is what we're comparing everything to, is these are the reference site. That's a measure of how well are you modeling expected condition. So the smallest variance was the model where we took geoclimatic variables. We also took human disturbance variables and we set those to the lowest value we could find in the ecoregion. Now, the second thing is how well do we distinguish between this? And if you remember, the 5th percentile was below the 5th percentile of reference was what we determined. Don't have a steady enough hand, but what we said was anything below that whisker there is poor. Again, this is least disturbed, minimum or medium, and most disturbed human footprint, not sediment. So when we go across here, the only variable that the model that has the 5th percentile actually excludes most of the most disturbed sites is the model where it's not maybe surprising that reference sites actually have disturbance in them. And so this was our method of trying to get rid of the signal of disturbance in our reference sites. So this is just illustrating that again, the same slide as I showed. So what we were doing was we were trying to reduce the variance of this enough so that the 5th percentile of it was able to distinguish this. And this, you can't see that this is, in fact, you can't read this at all, but what this is these were population estimates of the condition. I'm not intending to tell you anything about them except that it's the whole US riparian disturbance, red, yellow, green is good, fair, poor. It's a population estimate because it was built on the randomized sample, the grid sample, same thing that you guys used in the Transdisciplinar and Nova function. So that's the end product of this, is to be able to do that with the sites. Now, I don't know where I am, but one of the description, or one of the indicators that we wanted to add is hydro alteration, and I could go into that or not go into it. It's, you know, it's these are in papers. Okay. So usually with low flows, it's reduction in flow that we're concerned with. And in at least when I started, I thought, well, flashiness is the most important thing. But in lots of parts of the United States, it's reduction in flow in the magnitude of difference between high flows and low flows, because channel forming and cleaning out spines and channels is dependent on the flood. So here's an example from the Pacific Northwest, where if we look at all the streams together, and I'm going to show you why we have to classify, and is that we're seeing two things. And one is that this is the low flow, and we modeled the expected flow based on basin area, slope, precipitate, or excuse me, elevation, latitude, those kinds of things. And so this is the reference medium and high disturbance footprint. And you can see that the variance is lowest in the reference sites. And then when the more disturbance you have, the more increases in flood size and the more decreases in flood size. So it's more disturbance leads to more variability in both increases and decreases. And the same thing is true of, this is bank full flow. So they're more variable, but across the United States, contrary to what I expected, most of the effect was a decrease in flood flow. And that's generally because it's an agriculture, most of the disturbances are agriculture and things like irrigation, dams, and these sorts of things. So these are generally the urban streams, and these are agricultural and water supply, rivers flowing out of water supply areas. So what I did was I took Idaho, and so I'm going to a more consistent climate within this ecoregion, and I separated out wadeable and non-wadeable streams, big and little streams. So if I look at them all together, I see the same thing. I said, well, yeah, and this is low flows, by the way. That low flows are a little bit lower, but I'm generally seeing the same thing. I'm seeing more variability. But if I separate them out into the this is boatable large streams, and these are wadeable streams. The large streams are almost universally increasing in flow, and in that ecoregion, what the reason for that is that they store the winter flood, and they meter it out to have adequate water for irrigation, for waste dilution, and recreation. Now, nobody cares that much about the small streams. So generally what happens in the disturbed streams is mostly the low flow is reduced because you're drawing water directly out of the streams, and there aren't adequate laws to protect the streams from getting depleted in flow. So this is, if you want more detail on this whole process, there's ecological indicators a couple of years ago, 2-part article where we go in a lot of detail from field measurements to the metrics that you get from the package that we can give anyone on physical habitat metrics, modeling in various ways to get expected values, set anthropogenic predictors to a minimum, as I discussed. And then, so you get expected metric values, make an O over E, compare that with reference sites, set good, fair, poor, and then make estimates of habitat condition in the US or in the basin or whatever. And this is a figure from those articles. And glad to talk about anything else after that. That was during the World Cup. We were crying about an hour later than this. I didn't even dare to call any of my friends. I guess they had all hidden under rocks. I'm not sure, but it was a dark day in Corvallis as well.
Tem que ter.
Faz as mãos.
Agradece.
Passa essa
pergunta dele.
Essa aqui, ó.
Let's talk about fuel, and we have a.
After the question.
After the questions, okay. Question?
No questions.
So few. We are talking about a whole story, a big partnership, and we always learn much when you and Bob and other colleagues come. It's very, very interesting for us. Today, you saw in this meeting, you saw the difference between Uruguay, Brazil, Amazonia, and Southeast Brazil and South Brazil. You know, you showed us the physical habitat variables and parameters, and also the anthropogenic ones. And you see in this little example of the whole South America, very distinguished differences, like Uruguay. We are now in 800 meters high from sea level, and the biggest one there is around 500 in the country. So you have quite differences. And what do you think about choosing those anthropogenic influences, since you see there are very different in the same country or in the same continent?
Two things. I've been really surprised, and I was asked to do this for the United States, and I think I showed this thing where I was sent to the desert to meditate for 40 days and 40 nights to come up with the dimensions of habitat or the protocol. But seriously, I thought that this would be less universal than it's turned out to be. And so we've applied this in Europe and Belize and actually mostly in Brazil. And I've been very surprised that not only does it seem to work okay, but it works in so many ways better here than it does in the US. And I think that some of the reasons for that is that there's a longer history of disturbance in North America, for maybe not since the inception, but it's, if you pick a random place in the US, it's generally been disturbed for 300 or 400 years. And there's areas that have grown up forested 4 times in the Northeast. So I guess getting back to, I think that some of these things the physical things are based in, there's only a few things that can affect sediments: lithology, slope, how much erosion there is, and the size of the stream. It's not as complicated as biology, where you have to say, well, what's the organism like, and how did it get there? There may be a place where it really likes, but it never got there. So there's evolutionary history that you have to contend with biology, whereas if you're looking at habitat, it's more physics. And the other question was, you asked about the anthropogenic. In fact, that was your main question. And if you look at the types of disturbances that I looked at, they're very general descriptions, but we did them within ecoregions. And there's 9 ecoregions that we aggregated in the US, and they were put together for reasons of having similar climate, similar geology, similar biology, and so that we expect that when you say agriculture and it's in the West, that's actually probably irrigated agriculture. It might be hay, whereas if you're in Iowa, it's probably corn and it's not irrigated. But since we're modeling in a different ecoregion, the predictor variables, or the slopes and the beta values for all those are different. And so that the model has a different, may have the same variables, but different parameters in the model. So I can't say much more than that it's, we measure it, the success by, does it help us manage? Does it help us predict what is good and bad? And do the biota care when we show the biology, or when we show the biota the results? And do they respond in the way that we would expect them to?
Well, thank you very much for the presentation. I think it's good to see your perspective of these results. Well, my question goes in the way that since you and Bob came here first time to train people here and to develop the protocol here, well, Callisto and the colleagues have been applying this protocol, and at the moment we are daring to discuss about the metrics and discussing about the protocol itself as we did here, given the conditions, given all the constraints we have. I would like to hear from you what you think of what you envision as the future of the protocol, what you think that is working better since the time you developed the protocol, and what can be improved. What is our role in it?
Yeah, well, one of the things that we're trying to do, and we're under the same kinds of constraints as you are in type, in that they're constantly saying, well, there isn't enough money. And in fact, the wetland portion of this that is going out next year are asked to, okay, you have to reduce 25% of the field effort, or you won't be, or you'll have to reduce 25% in the number of sites. So in the physical habitat, in streams, rivers, and lakes and reservoirs, particularly in streams, we're looking to replace slope measurements with LiDAR. And so we have a guy, kind of a guy with some skills like Diego, who's working on that. We're comparing where we've measured slope with either with the water level, or actually the water level was the first innovation. There's using complex or expensive surveying equipment like you'd use to make roads and bridges. That's pretty difficult to drag through the forest and over rocks and all this. And what we found was through testing is the water tube is not only easier and faster, but in this application, it was better it was more accurate and more precise than a total station using with survey equipment. But so we think that we can reduce by 1.5 hours times 2 people by using LiDAR. Then the next thing we're looking at is certainly for large rivers and hopefully for smaller streams, we're looking to use satellite imagery for riparian vegetation, for sinuosity, for we can use LiDAR to get bankful and incision. So that's the future in the near term, probably in the next 3 years. In lakes, similar things. The lakes is not as intensive as the stream and river protocol, but we're looking to do similar kinds of things. Certainly the cover of vegetation is not something that I think it's actually not even ideal. It's better to do it from satellite than to be there and imagine what it is. So the protocol is growing up with the increases in technological quality of data that comes from technology. I'm trying to remember if there was more to your question than the future of the protocol. There are some issues that you and I and Marcus have discussed about length, and maybe I'll just put out a suggestion. Is I've talked to a number of you separately of that I'm concerned about the length of the reach getting shortened and the resolution of the fallway, the mid-channel depth measurements. I think you're probably okay, maybe I'm closing my eyes a little bit, but you're okay reducing some of the measures to 6 rather than 11 for things like cover, habitat, complexity, those sorts of things. But especially for sediment, I think that the roughness measurements they're definitely necessary to compute shear stress in the stream and to compute roughness, which is we can use that. I've talked a lot with Franco about the importance, like if you're interested in how big a flood your stream is having in the season that you can't be there, you can estimate that using the channel dimensions, the slope, and the roughness. But if you've not taken enough detail in the fall wave measurements, which is not that much work, it's not as much work as the transects. A little bit more work of spreading that effort on 40 channel widths and making sure you have high resolution depth is, I think that would be definitely worthwhile. And I do have slides that I've shown a number of you that was all those decisions that we made were based on pilot studies over something like 10 years. And there was resolutions like you don't need to take 100 width measurements because it doesn't vary that fast, but depth does vary on the order of half a channel width. So yeah.
And thank you, Phil, for your talk. And it's a pleasure to meet you personally after so many emails I sent you to understand these metrics. Nice. As a fish ecologist, we have a real challenge to compare sites with really different size, like small streams with larger rivers, because the sampling protocol is totally different. So especially when we use abundance data, fish data, it's difficult to compare. So my question is, how about the habitat protocol? Is it comparable, the weightable with the boatable protocol? Is it okay? Is it fair to use in a single analysis of an entire basin?
For specific things, like if you're looking at volume of wood or something there, and I need to tell you the variables that that we have to adjust for that. So there are differences. For example, when we're doing the bed stability in rivers, the whole thing is based on feeling the substrate in the middle of the channel. So two different things. We're not looking at the size class of substrate across and touching it. We're actually dragging a pole on the bottom and saying, but there's an article by Joe Flodemersh that said, well, we can, they truthed it by diving and said, well, we can tell 6 different classes, not 7 like we use with weightable streams. So what is the case is that there's an offset. The substrates in the large rivers are coarser, not necessarily, I mean, coarser for just because of those two things, you know, that you're in the middle of the stream, it's coarser in the middle than it is at the edge. So that a lot of that is we take care of that in the modeling. So we model separately large stream, potable streams. I almost never put the two exactly together without some adjustment. So I guess the same, I think, would be true of fish. Like if you're looking at relationship between basin size or width or something at fish species richness, I think you have to look at those. Maybe you'll put them together if it makes sense, but I think usually you get something like this, you know, you get 2 lines. And so, yeah, I think that you do need to be careful putting those protocols together.
Yeah, thank you for the progress. Very nice. I have a question about the reference site. I think some part you already got up. If you remember, for example, for Uruguay, you remember the map. Uruguay is a small territory. We have a different land use around of the country because these different land use are associated with the different soil types, geology, and slope, and other things. And in particular areas that are different, or we expected a difference in fish communities, for example, maybe we have not reference sites because you have a particular land use. In this aspect, we have maybe the reference sites or the more best quality sites are totally different of the I don't know, of the other regions.
That's an excellent, actually, that's the center. We have a whole, oh, excuse me, excellent question. And we have a couple of postdocs working with us on that question. And one of the things I didn't mention because I was looking at Bob, and Bob is always knows that I talk too much and write too much. And what I forgot to say here is this modeling does not distinguish. We use all sites. This one here used only reference sites, and always I think that in most cases the reference sites are disturbed. And not only are they disturbed, but they're in special places. So we're really trying to get completely away from the idea of reference sites, except for one thing. And so in this one, we used all the sites in the Southern Plains. So this is like 2.5 times as many sites. And we use natural variables and local, mostly riparian disturbance. So we factored those out or corrected that out of the regression for expected condition. And underlying that is that, at least for habitat types of things, almost always the natural gradients are dominant. And so, but if you have that reference problem, you're actually selecting, like, let's say if I'm working at Corvallis and I take the Cascade Mountains with no disturbance, how much less in saying, well, that's the reference to compare down in the valley where there's lots of farming. So what we do in a case like that, we first model, we force into the model things like slope, basin area, lithology, ecoregion. And then the second part of the model is we look at the residuals of that and factor out then these kinds of variables. So we fit the model twice, first to natural variables, second to anthropogenic variables. But then in the final analysis, and it's something I'd like to get away from, is we do take, what's the next slide? We do look at the OSU values that we derive from all sites, modeling out the disturbance. But we look at what is the O/E value in reference sites. And that's a weakness. And I think we want to get away from that, but it's difficult to do.
Thank you. We are close to the coffee break.
Yeah.
I will ask you something that I'm curious about. After we know from here that there are many dam removal in the Pacific coast and the United States, even in Canada. And did you come back to those areas to sample, like to redo the IBI or MMI in these regions or rivers?
I haven't, but I have a colleague at Oregon State University. I don't know what's her name.
I'm not that asking about if you did, but
I have
EPA did.
I have not, but I would be eager to do so.
Have you done that?
To do that for
The best study is in the state of Washington, Blind Canyon Dam, which was about a 200-meter high dam. And it has a sister dam with it. And the indicators were mostly salmonids and sediment. And the reservoir was chock full of sediment, but within a couple of years, and mostly moved out except in the floodplain. And the salmon came back in months. And the Klamath dams that were just removed, I think the last one was moved this spring. The salmon are now up where they've never been in 150 years. So big migratory fish, these are Chinook salmon, these are monsters, they can adjust. They were just waiting for humans to become wise.
Thank you.
Yeah, Panderos has got to go.
Coffee break? Tem mais duas apresentações, mais homenagem. Thank you very much.
What is it?
Thank you very much.
It's milky. Thank you very much for coming.
Very good. Very good. Okay, thanks for the
Please, people, sit.
Thank you for the opportunity to present my work to all these great researchers here, and it's been a real pleasure listening to your work over the past 2 days. Yes. I thought that was laser.
Well, the cheap ones in top is a laser,
Yeah.
and the bottom
Bottom
one
is
is forward.
forward. Bottom had to be forward, right?
Yeah. Southern Hemisphere, yeah, that's important.
So I work with Phil Kaufman on the US-EPA's National Aquatic Resource Survey Program, NARS, and I'm a biological indicator lead for zooplankton, phytoplankton, and diatoms, and I help develop biological indicators like diatom indicators for the NARS assessments. So we've heard a lot over the past 2 days about fish and macroinvertebrates, but what about the diatoms? So today I'm going to talk about what are diatoms and why should we care about these tiny organisms? And then I'm going to talk about diatoms and biological assessments and the problems with diatom taxonomy that's prevented the use of diatoms in aquatic assessments. And then I'm going to talk about how we can use genus-level taxonomy and diatom traits that avoids those taxonomic problems and can help develop simple and cost-effective diatom indicators for state, regional, and national assessments. Okay, so what are diatoms? And some of you might be familiar with diatoms, and some of you may know absolutely nothing about them. I know when I worked for an environmental consultancy in South Africa, my manager kept referring to diatoms as animals. So just to be clear, they are single-celled algae. And they're the only organisms on the planet that have cell walls that are made of silica, which is essentially glass. And they're really small. You can fit 10 of them on a pinhead, so you need a microscope to look at them. So why should we care about these tiny organisms? Well, diatoms play a huge role in keeping the planet's ecosystem working. So some of you may have heard the expression that the Amazon rainforests are the lungs of the planet that produce 20% of the Earth's oxygen. But what you might not know is that diatoms also produce 20 to 30% of the Earth's oxygen through photosynthesis. So you're breathing the oxygen that diatoms release. Diatoms are also a really important food source for oceans, lakes, wetlands, rivers, and streams. These are energy-rich molecules that are food for entire food webs, from zooplankton to aquatic insects, to fish, to whales. So diatoms provide many important services. So diatoms are the most diverse type of algae, and there's estimates between 20,000 to 2 million species, and scientists are discovering new species every year. And they're found in most aquatic habitats. And different species have different ranges and tolerances to different environmental conditions related to pH, nutrients, salinity. And they also have different tolerances to different types of human disturbances. And so according to the European Water Framework Directive, diatoms are a compulsory biological group in ecological condition assessments of rivers and streams in Europe, along with other biological groups like macroinvertebrates and fish. So the benefit of having all three biological groups, diatoms, macroinvertebrates, and fish, in your aquatic assessments is it can tell you so much more about the ecological condition of the water. So diatoms are best at responding to changes in water chemistry, while macroinvertebrates and fish are best at responding to changes in the physical habitat, like the presence of dams or changes in the riparian habitat. And so by having all three biological groups, this can provide complementary information on aquatic health. So one of the EPA's long-running aquatic programs is the National Rivers and Streams Assessment, NRSA. And for 20 years, they've been collecting diatoms along with macroinvertebrates and fish, but they haven't been able to use diatoms in their assessments yet because of the challenges of identifying diatom species that has led to taxonomic errors and inconsistencies in the data, and that's prevented them developing an effective diatom indicator for NRSA. And the taxonomic problems with the diatom species dataset is not just a problem for NRSA, it's a problem for aquatic diatom assessment programs all around the world, including Europe. And so the one way that the Europeans are addressing this issue is using diatom traits in their aquatic assessments. So diatom traits are based on morphological, functional, or physiological features, and many studies have shown how well different traits respond to different types of environmental stressors. So for example, you've got your motile diatoms here. These are fast-moving diatoms that tend to be tolerant of disturbances like organic pollution, eutrophication, high turbidity. Then you've got your tube-living diatoms and your stock diatoms that tend to be sensitive to disturbances like high turbidity and high conductivity. And I'd just like to emphasize here that you can use both species-level taxonomy and genus-level taxonomy to assign the diatoms to the traits. But obviously the advantage of using genus-level taxonomy is it's much easier and faster to identify down to genus level. And so it's going to be, it's going to require less work effort, and it's going to be less prone to taxonomic errors and inconsistencies than if you're using species-level taxonomy. So we wanted to see if we could develop an effective diatom multimetric index, an MMI, using genus taxonomy and diatom traits to assess the ecological condition of rivers and streams across the United States based on the NRSA data. And perhaps the diatom MMI could complement existing macroinvertebrate and fish MMIs that are used in NRSA assessments today. So we developed 3 regional MMIs based on 3 major climatic regions in the US. So we have the West MMI, the Plains MMI, and the East MMI. And these are created from 9 NRSA analysis regions. So the West MMI includes the Western Mountains and Zurich, the Plains MMI includes the Northern Southern Temperate Plains, and the East MMI includes the Northern Southern Appalachians, the Coastal Plains, and the Upper Midwest. So to develop the MMI, we took the 2008-2009 NRSA data and we assigned diatoms to traits using genus-level taxonomy. And to assign to the traits, we used this trait database that was developed by French researchers Frédéric Rémy and Agnes Boucher. So just to give you some examples of trait assignments, if you've got species that belong to the Navicula genus, we would assign to the motile trait. Species that belong to the Fristulia genus, the tube-living trait, etc. We also developed genus metrics from the diatom genera. And then following methods in the Stodder et al. Paper, we selected the best final metrics and making sure that metrics had a wide range and good responsiveness. We then generated hundreds of MMIs with combinations of 4, 5, 6, 8, 10 metrics, and then finally selected the best performing MMI. And this table shows the final set of metrics in each regional MMI. And each regional MMI has a set of, a combination of genus metrics and trait metrics that are either sensitive or tolerant to disturbances. So how well do these MMIs respond to multiple stressors? So here we have results of the responsiveness of the MMIs. So how well an MMI can discriminate between least disturbed sites, that's your reference sites, and most disturbed sites, that's your stress sites. And so the box plots show a distribution of MMI scores between the least disturbed sites, that's your boxes in gray, and then your most disturbed sites, your boxes in red. And the greater the separation between a gray and a red box, the greater the ability of the MMI to discriminate between least and most disturbed sites. And we can see here that each regional MMI separates least from most disturbed sites really well, particularly the East MMI that has the largest separation here. So overall, these regional MMIs respond really well to multiple stressors. We also wanted to know how well do they perform on a completely separate site. So we took a totally different survey in NERSA 2013-2014 diatom data, and we tested the MMIs on that data set. So this box plots a comparison of the ability of the MMIs to discriminate between least disturbed sites and most disturbed sites based on the validation data set, the 2013-2014 data, and the calibration data set, your 2008-2009 data that the MMIs were built on. And we can see here that the separation between least and most disturbed sites based on the validation data set is just the same as it is for the calibration data set for each of these regional MMIs. So these MMIs perform really well on a separate set of sites. We also wanted to know if we could reduce the time-consuming diatom counting effort using these genus MMIs. So currently the NERSA target count is counting 600 diatom valves per sample. But what we found was that if we count 100 diatom valves, it works really well. That the MMI separated least from most disturbed sites the same at 100 counts as it did at 600 counts. And not only that, but the site condition class of good, fair, poor, based on the MMI scores, didn't change at 100 counts for most river and stream samples across the United States, and we were looking at over 3,000 samples. So what this tells us is that we could considerably reduce the processing time and reduce the cost of the analysis for ecological assessments using genus-level diatom MMIs and potentially other diatom indicators. So I found this in this Bennett et al. Paper. And in 2012, in the United States, the cost of analyzing one diatom sample at 600 counts, looking at species level identification, was about $500 per sample. But then Bennett conducted this survey of about 28 diatom experts. And on average, if you were to go down to genus level identification, it was actually going to cost $240 per sample. So by going down to genus level, you could reduce the analysis cost by more than 50%. And that's counting 600 valves. Imagine if you were to go down to 100 valves, you're likely to reduce the costs even further. And this genus level trait-based approach isn't just limited to rivers and streams. We tested it on a wetland national data set for diatoms from the EPA's National Wetland Condition Assessment. And they've had the same issues with taxonomy errors in their data that's prevented them from developing an effective diatom indicator for the National Wetland Condition Assessment. So using the exact same approach, we developed 4 regional MMIs for inland wetlands from 4 major climatic regions in the US, the East, the Plains, the West, and the coastal plains. And what we found was that 3 of these regional MMIs performed really well. There was nice responsiveness here, good separation between least and most disturbed sites. Less so for coastal plains, and that could be because we had few least disturbed sites to work with, and we definitely need to sample more sites in that region to see if we can improve the MMI model. But the bottom line is we can use genus level taxonomy and diatom traits to develop diatom indicators for national wetland assessments and potentially other types of aquatic systems. So I did this quick search and typed in diatom traits and reservoirs. I was thinking about this workshop, and up came this article, which is relatively close to home in southern Paraná in Brazil. These guys might be the only diatomists in Brazil, but still they found in this paper that the diatom trait responded really strongly to environmental changes in reservoirs. So there's potential there to develop effective genus trait diatom MMIs for reservoirs as well. So just to conclude, these genus MMIs can effectively assess rivers and streams and wetlands at large spatial extents. And just to highlight some of the benefits of using these genus MMIs is that it can use genus level taxonomy. And so that's going to require less expertise, less work effort, and it's going to be more cost effective. And that could really benefit aquatic programs with limited resources. Because they use genus taxonomy, they're going to be less prone to taxonomic errors and inconsistencies. So these MMIs are robust. We also keep the information of all the taxa, including the rare taxa. So if you can't describe an undescribed rare taxa down to species level, it doesn't matter. As long as you can describe it to genus level, it will still be included in the calculations of the MMIs. So we're not dropping any undescribed rare taxa, and we're not losing any ecological information in the process. And then finally, if you have older diatom data sets, like NERSA that's got 20 years of diatom data, we can salvage these older data sets. We can run the calculations of the MMIs and look at historical trends in freshwater condition. And so with that, I will conclude and happily answer any of your questions. Thank you.
Thank you very much for your talk.
Okay, thank you.
Any questions? Luisa, first, thank you very much. This is a new word to me, so it's interesting to see. I was really impressed by information you brought here. Maybe my question is, well, too naive because I don't understand actually. First, what are the traits that you use to identify diatoms? And when you mentioned the 600 valves, for example, what is the size of the sample there? What does it represent in terms of sampling efforts and the number of species you, or general, of course, you get from the environment compared to what is there? I mean, how representative it is and how much do we need to sample to get maybe enough data for diatoms?
So was that me or you? I think it depends on the objectives of the study. So if you're looking at an ecological condition assessment, what I've shown here is that 100 valves was fine. If you're going to do like an over-E model and you need species richness, you're probably going to need 600 valves, maybe even more. If you're looking at species richness, and I know a lot of folks have, focused on that, but for a simple ecological condition assessment, then, I demonstrated that 100 valves was adequate for that. And then the type of traits you have, so you've got gills and where they're positioned within the biofilm. So for example, your high profile gills are high up in the biofilm, and these are more sort of sensitive to disturbances. Versus you've got your low profile gills, and those are often diatoms that can move. And then you've got your life form traits as well. So these are all basically functional type traits and how they compete for resources, nutrients, light, etc. And I did actually try morphological, so looking at diatom sizes. Didn't work for this study, but that doesn't mean to say it wouldn't work for another study. Yeah, so basically I was focusing on functional traits. I also have one physiological trait here, which is looking at nitrogen fixing cyanobacteria that lives inside the diatom. Yeah, so.
Thank you.
Luisa, thank you very much for coming, first of all, and thank you for your clear, objective, and very inspiring talk you offered to us. We learned from you and also from Thaisa about the importance of including the primary producers in our assessments and in our big projects. But I have some doubts after your talk. The first, which is very, very basic. How do you collect your samples? How do you choose the substrate, and how can you be sure that how can you be sure that the colonization of diatoms are comparable? I mean, if there's a stone that is stuck in the sediment for 10 years, so I assume that the diatom colonization would be different compared with a small piece of substrate that is there just for a week. How do you collect the diatom samples, and how can you compare different substrates in your assessment?
So typically the EPA for rivers and streams, they look at the 11 transects, and for each transect, they are only sampling one stone per transect, and then it's composited into one sample. Well, I mean, we've found there's been studies that have shown that there is no difference between substrates, so there's no bias with the type of substrate, but they prefer to look at a rock, scrape it with a toothbrush. I think with diatoms, they sort of not recolonize, but the population is changing sort of every few weeks. And it's possible, and I'm not 100% sure about this, but because I don't do the actual analysis, but they might look at the amount of dead diatoms versus live diatoms. And I'm not 100% sure about that, but I can look into that.
Okay. The same line. You said about the cost of sample analysis, but this you assume that all the species are well known, isn't it?
Well, that taxonomic data set.
Sorry?
General.
Yeah, because so I was looking at the genera because the species data set was a bit of a mess, to be honest. And
okay.
that wetland data set, that was collected in 2011 as a pilot study.
Okay.
It was a disaster. They put it into a cupboard and never talked about it again. So maybe I'm revealing too much here. That's the reality. So I showed that we could use the genus level taxonomy with such a messy data set at the species level.
Because you compare the cost of species identification, almost 500, and the cost for genus identification, almost half of this. So this quantitative is very important in this analysis. But my guess is, do you think that even at the genus level, the knowledge of the diatom genus level is worldwide homogeneous?
Yeah, I would say genus level. I mean, they send it to labs who are taxonomists, who are diatom experts. I would say one is pretty confident at genus level, and then it's the whole arguments of what species is that, and no, it's not that anymore. It's become something else, and that's constantly changing, but less so with the genus level taxonomy, that the nomenclature is constantly changing. So I would say it's more stable, it's more robust using genus level taxonomy, and it's identified more accurately.
Great. And my third and last, I promise. My last question is about in both papers, and I read both, they are fantastic. In both papers, you worked regional assessments, not a whole US assessment. And since we met Bob, he has been pushing us in order to try to have a single method for all country, for our country. When Leandro and Thaisa came to this workshop, one of our objectives were not only to increase the discussion, the national discussion, but also to realize, and Franco also did this, how different the systems are in terms of all features we think. As far as you have this experience with the US database and looking to other countries or continents, do you agree that it's hard to have a really wide index that can be applied everywhere, or and your aspect. You understand, right?
Yeah, absolutely. So I wanted to see if a national MMI would work. Just you got to test everything, right? And it wasn't horrendous. It was okay, but I decided, right, let's see a finer scale. Let's build regional MMIs. I also built MMIs for the 9 NERSA analysis regions. And in the end, they were comparable to the regional MMIs, and it's much more simplistic to use 3 regional MMIs than 9 NERSA MMIs. So I tested at all different spatial scales at how the best performing MMI, what scale was that going to be? And it was going to be for the US, it was the 3 regional MMIs. I mean, with the diversity in Brazil, it was more than likely that you probably need regional MMIs as well, given the difference in biomes across the country. And I also just want to say one thing, sort of going back to the genus taxonomy, that, to not be scared about analysing diatoms, that I'm self-taught, I never had any training courses. Maybe that's why I didn't like species level taxonomy, but, it's not that difficult to ID down to genus level. And even at species level, it's not so bad either. And if you've got your books in front of you, anyone here could teach them. If you had a bit of patience, it's, if you've gone through identifying and learning how to identify macroinvertebrates and fish, I don't see why you couldn't do it with diatoms as well.
Thank you, Luisa. I think there's a bit of a modification to the survey. You can also, EPA also collects diatoms from soft substrates. Some places not rocks or wood, but they use a syringe and suck up just a lava that contains diatoms as well. They're in the sediments. They clean that, so you can get them from any substrate, and it's quick. I mean, it's 1 minute. I think 30 seconds. It's very quick. Yeah. And for those of you that are wondering if you can identify a diatom, I can identify diatoms for genus as a fish biologist. I did that. My first 2 papers were on diatoms. Beautiful. You can, now my eyes are not good, but it's not hard. You learn the genera by shape, and you check it. And then their shapes look a lot different. So it's, in some ways, it's the same as learning families of macroinvertebrates, but you can see them in your hand, but you should see them in the microscope. The key thing that Luisa has done is she stepped into a program that has data already. And we agreed when we started EMAP and NARS that we were going to collect diatoms because they're a very useful indicator. And we had scientists that were diatomists in the program, trained diatomists that had PhDs in diatom taxonomy. One was killed in an airplane accident, and I don't know what happened. The other one, but we lost that expertise. Now we have Luisa. Don't stand near airplanes when the propellers.
I'll just stay here forever then. Nice, I like it.
2 other points. And we talked about this on our way to lunch. If you have heavy metals, those of you that are working in mining problems, these are really good indicators for deformities. You can look at a diatom that's a beautiful structure, and then, very clean pattern. It becomes totally different. You can see it. Anyone can see that. And you have serious mining problems in this country, just like we do in all countries. And I don't know if you calibrated your metrics. I forget if you said that, how you calibrated for natural gradients.
I didn't.
You just used the ecoradiance.
I deliberately didn't, and I know you've talked about this in the workshop, but for 2 reasons. Firstly, the folks at the EPA don't calibrate for natural variability, not in the NARS team. And secondly, I wanted to make this methodology as simple as possible so that you don't have to have complex modeling techniques, that anyone can do this just following the cookbook step by step. It's not complex modeling. It works really well without modeling out the natural variability.
Another cool thing, for those of you that are working with reservoirs, these, as Luisa hinted, are ways to look at the history of the reservoir. You take a sediment sample and you can see how the diatom flora changed over the time. And we do that on lakes. I mean, I think our first project in the northeastern United States, we went down 50 centimeters of sediment. That gets you back to when the lake was formed, when the glacier left. So you can see how the nutrients change, how the sediments change. So we can go back in history. This is a really powerful tool, and it's doable.
Yeah, I've also built MMIs in South Africa, specific to mining and acid mine drainage, and looking at lots of deformed diatoms. But that seemed to work really well. So I don't know.
First of all, nice work. Congratulations. My question is about in Rio de Janeiro, when you have a wastewater treatment plant, sometimes the environmental organ asks you to make an ecotoxicology assay on your wastewater effluent. Usually, you have to use two levels of trophic levels. So one of them, usually they use that fish at then you had it. And
Zebra mussels?
Zebrafish.
Oh, zebrafish. Right.
And another one is daphnia.
Right. Yeah.
Is diatoms usable in this kind of ecotoxicology test for wastewater?
I mean, yeah, I don't know about ecotoxicology, more about you look at the assemblage, the species that are there, and it's screaming out sewage. You've got your usual suspects that, I can list the names of the species that are very easy to identify and, very typical of sewage effluents. I used to work for an environmental consultancy in South Africa, so that was the kind of work that I was looking at. Sewage effluent was one of them, and yeah, absolutely, they respond really well to sewage and pollution. But in terms of ecotoxicology, I don't think diatoms would be used in that application.
Good. Thank you.
Anyone more? Just a curiosity, how do you sort the 600 or 100 individuals from the whole sample?
So you need a lab, and you need what in the UK we call a fume cupboard, but sounds very old school. But basically, you're dissolving the organic material. So you got your sample, you dissolve the organic material in the laboratory, and then you have your material and you place it on the slide with the cover slip, you seal it, and then you look under the microscope and you will have hundreds of diatoms, in that slide. And so really, you might be looking at, 600 valves, and it depends how dense the valves are. So it depends how well they've been prepared. But yeah, you basically look at a few transects and you do your counts.
Thank you.
Thank you very much for your inspiring talk.
Thank you, Andy.
It's a pleasure for you.
Thank you for all the good questions.
I would like to invite Steffen for the next talk. It's
Deixa que eu fique um pouquinho, quero ficar em pé.
Obrigado. Esse é o último. Temos dois provérbios na Suíça. Os últimos são os primeiros. Positivo. Negativo é o último é mordido de lobos. Então, para você, eu fiz uma luz um pouco escura para estes que prefiram de dormir. Outros podem ouvir na minha apresentação. I will continue in English with respect also to the American guys, and with also with the velocity how fast I can speak that this workshop can end somehow. So the title of my talk for the topic for the next 20 hours, in minutes, is Swiss energy policy and aquatic ecology, insights into my heart. And so I'm an ecologist working for hydropower plant. So I see the positive effects of hydropower, which is necessary, I will show you later. But I'm also an ecologist and I see the impacts. So the content of my talk is I give you a short introduction, then I will show you what's going on with the energy sector in Switzerland and in Europe. Then this is related, why are we doing our extension projects and ecological measures, how we do it in Switzerland. And then I will talk a little bit about fish migration with a movie and end up with hydro-peaking and some research projects. So the idea of my talk was, Marcus invited me, thank you very much for that. I hope you're still okay with my invitation. So he said we have, oops. Not so engineering. So my content should cover some research for the audience, research students, for the hydropower plants, for agencies, authorities, and for private consultants. So first, where I'm coming from? I'm coming from Switzerland. And when I was at the airport a week ago, I thought, I'm coming from Switzerland to Brazil. I should maybe bring something to you. So what can I bring? I think it's clear I bring you some chocolate. And Gisele will... So I will continue. So I was thinking, maybe you will not enjoy my talk, but you will enjoy definitely. So trying to be serious again, which is always hard for me. Switzerland is here situated in the middle of Europe, and the village where I'm working, we have about 800 inhabitants, is situated here in the center of Switzerland, but in the place somewhere nowhere, directly in the Alps. So now this was the reason why I wanted that the lights are a little bit off, that you get a better impression of the photos. So this is our largest lake. It's called the Lake Grimsel. I will talk later a little bit more about that. For Electrobras, I don't know, but the amount of this lake is not so, with 100 million cubic meters. For you, it's not so much. But anyhow, we have a lot of height, so that corresponds to 220 gigawatt hours. So it looks like in winter. So this is our water. When we have a very good winter, you see here the guys. And this is our residual flow stretch. A fisherman paradise.
our forests, and yes, we have also an ocean, but only a fog. This is at the moment the case. So, I don't know, maybe one of you or two of you in the audience have ever heard about Interlaken, or maybe about, it would be situated here. Then here would be the three famous mountains called Eiger, Mönch, and Jungfrau. Maybe someone of you heard it. In Europe, they are quite common. In red, we see the watershed of us, with our big reservoirs, Lake of Crimson, and others. I will talk about that. And later in the talk, also about here, there's pressurized the new lake. It's called the lake Rift, with retreatment or due to retreatment of the Rift glacier. So some facts about Kraftwerke Oberhasli. We have about 300 full-time positions. We produce 2,200 gigawatt hours per year, which is around 5 to 10% of the total production in Switzerland. We are the biggest scheme. For Brazilian scales, maybe more than a bit like diathlons. The annual precipitation is 2,000 millimeters, with a mean discharge at 35 cubic meters per second, where the water is coming out. Yes, we have 10 power plants, and the catchment area is only 420 square kilometers. So coming to the energy sector, you see here from January, winter time, February, March, winter, then it starts with the spring, summer, and here at November, December, the winter again. The black line shows you which is the demand, and the bars show you how we produce. So the yellow ones, the yellow ones are the nuclear power plants still existing, about contributing 30%, a third of it. In blue, the hydropower plants, and in green, the rest, it's a little bit of photovoltaic and thermal production. So you already see in winter it doesn't match. And I'm not an engineer and not an electric engineer, but this, not a physician, but what I understood is each second you have to match energy production and consumption. And so you see here these holes in the winter already for the last 20 years, in 19 years, Switzerland had to get energy from outside. So we are talking also about the energy plan in Switzerland. So I made a mistake when I make the presentations very late. There can make, of course, some mistakes. That means 2035 to 2050. The idea is that we'll have a higher demand due to electric mobility and pump heating that will shift here these dotted lines, which is the consumption up. We will have in future no more nuclear power plants, so we will lose a third. We may install some photovoltaic, but this produces not so much in winter, and it's not able to schedule, which is very important. And maybe we have the possibility to increase a little bit to hydropower. This plus 5% is quite optimistic, because Switzerland has already a lot of power plants have already been installed. So what we see, these gaps in winter are getting longer and much higher. So what to do? The first thing I would say, but I'm an old hippie, just to say, maybe we should reduce our demand, but I'm a realistic too, and we're living in a capitalistic system, and reducing is not that famous word, it's usually growing. So in future, we will need more stable hydropower in winter, but we will still anyway be dependent on the European Union. This will, as it is. We will have maybe a little bit more on yellow the photovoltaic, blue the hydropower, but still we're seeing the gaps are getting bigger. So how flows, that's another point, how flows the energy and how flows the European Union. You see one example. In Italy, there was the demand of energy. It was produced in Germany, went to Poland, Czechia, Germany again, France, passed through Switzerland without asking us, and going to Italy. This is just the way how the electrons go. That means Switzerland is really in the middle of the European Union, but it's not part of it. But we are facing all these electrical variations, and we have to stabilize always the net. And also for that, we need more power. Looking into the future, Germany has already replaced all nuclear power plants. They try to replace the thermal powers. I don't know how they will do it, 40%, 50%. They will have a deficit in winter, I guess, too. So we can't rely on them anymore. Looking at France, the next big neighbor, 80% of them has nuclear power plant, all the same type, all more or less the same age. If I would have some money and give it to a banker, I would do that. But they did it, and when there's we have seen in the last years, if there's a problem in one nuclear power plant, one special problem, they have to look all others, and usually a third of it has the same problem then. And then they have to shut it down for several months, a third of the power. So that was new in Switzerland. There was a round table for solving this problem, a national-wide round table, which usually in Switzerland is not common because we have 26 cantons or states, and everyone is doing its own business. So there was a negotiation with NGOs like WWF, fishermen and so on, the cantons, federal agencies of energy and environment, and the Association of Swiss Hydropower. And they really could fix a goal to have more, in 2040, have a plus of 2,000 gigawatt hours additional and storeable winter energy coming from hydropower. And they looked at many projects, and they selected the 15 best ones with the best ratio of benefit and impact. And we think they did a good job because 3 of the 15 projects are including on our list. But this has also confirmed by the public voting. You know, in Switzerland, we can vote if something is not, if somebody doesn't agree, he tries to get a lot of signatures, and with 100,000 signatures, the whole Swiss persons can vote and decide to do it or not. So this was a quite clear yes. And we have to do, besides the ecological compensation, I will show you later, additional measures, which is still no progression. So coming to the projects, first is this project Drift. You remember on the map, here was a glacier until 2000. Now there's a lake. And this is the other perspective. The idea would be to build here dams. There's a photomontage, it's not done yet. To enlarge the lake, and with that we can increase the wind energy to 250 gigawatt hours, what means 13% of the national wide perspective of the round table. This project started already 11 years ago, so last year we had the 10 years anniversary, but no dam. And until now, no concession happening. Sure, we have ecological impacts, and that's also the other side of the coin. You see here a photo. The glacier is actually, I guess, here at this level already retreated. We flood land, and we have enlargement of the residual flow stretch. Below, we have already a water intake. So these are the ecological impacts. We did a lot of ecological investigation, so it's really, we apply it. We are looking at fish, sure. We are looking at algae. We are looking also at water plants. Diatoms, we don't have to yet. Macrozoobento, sure. Floodplain vegetation, terrestrial vegetation. So there have been done a lot of investigations of a lot of experts. I think we looked around 20 or more different species or kind of species. What we also did was a very intensive participation process. This is our style, how we are developing our projects. So talking with the NGOs, with the cantonal agencies. Also we have research, a link to research. We have sometimes research projects. Yesterday there was a discussion, but it was so long, so I thought it's maybe not necessary to add it, but we have this, and for us it's always, or for me it's crucial that we have an independence of the research, and but still we can discuss about how to do it and how to interpret. But it has all its limits, and everybody at the end has to agree with it. So finally, 100 persons participated. It took us 3 years, 50 meetings to find a compromise. What was very important was to develop in this participation process, to develop an evaluation system to evaluate the aquatic impacts. We did it together with the cantonal agencies or authorities and the NGOs. And for that, we developed 6 different indicators: residual flow, flood and sediment dynamics, river morphology, floodplain forest, aquatic habitats, and landscape, which is also a very important aspect in Switzerland, also written in the law. And you see also they are differently weighted. I don't have time to go more into detail. If you have any questions later, you can ask me to that. And so we got a minus. We can calculate so-called eco points. We got a negative balance of 10 eco points due to this residual flow stretches with a medium ecological potential. And we have different ecological measures like a removal of a very big water intake, conservation of rivers, and river revitalizations, which you see here with the same length. These are our measures. This is an example for river revitalization, how we could widen it. 2 rivers in our system. For the terrestrial impacts, we also have an evaluation system not coming from us. This is already developed from Switzerland, a protocol based on aspects like rarity, biodiversity, endangered species, and the age of the ecosystem. So here the measures for the project are a forest reservation, to start with that, protection of dry grassland and pastures, which have a very high biodiversity. You see it here, an example with the cows, and it's not me. And yeah, it's very important to keep these pastures open with a very high biodiversity, because you see it also here, because the farmers usually prefer to use only the land in the valley. We have also special measures for snakes, amphibians, and lizards, and mitigation measures for wetlands. So finally, we could find with all participations a good solution. And the but will come a few slides later, because we have a second project, which I represent, is enlargement of the Lake Grimms. You remember the photo at the beginning. We want to enlarge it to the 2 dams, about 23 meters, increasing the volume about 100 million cubic meters, and increasing the storage capacity to 220 gigawatt hours. So here we have also ecological impacts. In particular this is the glacier. I've just been 2 weeks before I left to Breslau. I've been here. It's now maybe around here, already retreated. We will flood this part of the glacier, we call Gletscher Vorfeld, so the place which is now currently is getting recently free of ice. And for that, we have to do ecological measures. And also for that, we did a lot of investigations. So the project history, we started in 1999. I started in 2007. We have been 3 times at the federal courts, before 3 times at the cantonal court. Still no decision, no final decision. And we could start this participation process with the NGOs last year, and it was a very quick thing, and we could really fix everything besides these additional measures which are not clear at the moment. So here we had this year the 25th anniversary. Our CEO knows this slide and he has a good for more, but it's how it is. For here we have also aquatic measures. We increase the residual flow and sex water intakes. We have river revitalizations, and terrestrial. There's maybe also again a revitalization of wetlands, removement of cows and sheep in areas with a very high ecological potential. We have also a ranger installed that we can control this here. Usually this is crystal. With the social media, this has become really, and with the corona, this has been really become crazy, how many people we have in the summer here. And measures for snakes and amphibians. So now coming to the beds, to the bugs. Where do we stand with the project? In Switzerland, there's the right of objection. And I totally agreed to that. I'm really a democratic person, democratically thinking person. And this is a right for the NGOs. So if somebody disagrees with the project, with our work, he has a right. And then it has then the court to decide. And for both projects, 1.5 NGOs made objections, 1.5, the half because it's a small one which cannot go to the federal, only to the cantonal court. So maybe the next time when I'm in Brazil, I can tell you more about that, hopefully. So coming to the fourth part, the fish migration and the Swiss laws. You have to know that usually the concessions for hydropower are lasting 80 years. And there you define mainly the residual flow depending on hydrology, fish migration, invertebrates, floodplains, landscape issues, and endangered species and habitats. This is one thing, and a lot of concessions will have to be redone coming the next years. And until 2030, so we have 6 years less, around 1,000 obstacles due to hydropower have to be passable for fish up and downstream. And around 100 cases with hydroponic. I will explain that later. So we did it already around 15 years now, or 12 years ago. We installed a fish lift. I will show it to you here. We have here a small reservoir with a high difference in height level of 2 meters. And so we can't just build a fish ladder to connect it. Wouldn't be very, very ambitious. So we decided to make a small fish ladder, leading it to the fish lift, getting the fish up, and then getting them out. And now maybe I need some technical assistance. Can you see here the fish lift? So this is being off all the main fish down out. Here would be the entrance. That was quite big. We did it with wood, so we could vary it if it would not work. We also have other species, like a mother also. So at the end, here is the entrance to the fish lift. Before the fish, the box will be lifted up. It's getting close. Move it up. We made 3 photos per each fish. And it's fit. In this straight line, there. So this is how it works. It's done by Matthias Meyer. Christoph avoided the movie for the Red Mine. This is maybe not for children now. Anyone? Posso continuar? Ótimo. Não, talvez. Ótimo. We could show with the photo that really the amount of fish which is living downstream is usually in 1 year is moving upstream. We have also seen some fishes which have done it 2 times, 3 times per year. And I don't know how they like it. Until now, we have no obligation to ask a fish psychologist, but usually it's working. So coming to my last point, it's hydropeaking. I don't know how famous this topic is here in Switzerland. It's quite, it's a hot topic, a hot potato, I think you say so. If this would be the natural discharge here in time, when we don't produce, the discharge below our power plants is low. And then when we start production, it can rapidly increase, being on the top, and then after production, it can decrease again. And we have effects like the minimum flow or the maximum flow, that there's a changement in habitats, depending on flow velocity, water depths. We may have some drifting effects, that when it's getting too fast, I will show you later the results. Invertebrates and small fish can be drifted away downstream. And if we have parts of the riverbed which can fall dry after such an event, there's the chance or the risk of stranding fish. So for that, we did really a lot of stuff of investigations to know it. Finally, all these investigations showed that the main problem in our case is the drift and a little bit the stranding. So, and the drifting experiments showed that instead of changing the discharge in 2 minutes, to do it in 30 minutes or an hour, so the invertebrates have enough reaction time to go into the sediment when they feel that the power is getting bigger and bigger. Helps a lot. And for the stranding, we know at when discharged parts of the riverbed can fall dry. So our solution was finally a construction of a basin. This is 20,000 cubic meters, and we have 60,000 as a gallery installed. So we can reduce these ramping rates, or maybe not mathematically completely correct, but the volume between these two, here and here, and here and here, this defines the size of the basin. The monitoring program was also quite intensive, and we have been very happy because we didn't know if we match it, but finally it revealed that all ecological goals could be full, or in some cases even overfilled. But we have 99 other cases in Switzerland, and I really had not a really good feeling. What is the right volume? Is it 80,000? Is it 50,000? Is it 500,000? And just looking at the costs, this project costed 35 million of Swiss francs. So I guess 40 million of US dollars. And we have so many cases. And I'm really not. So I was pushing, even in 2011 when this law was installed, I already pushed my old friends at IBI-UHE, please, we have to do something for hydropeaking. We have this new law, we have, but almost nothing happened. So I was like a young child. I was always, we have to. And finally, the Federal Agency of Environment sponsored us a research project which we conducted together with fish experts, these training experiments. So here's the water coming, flowing here to here, and below that there's a cage where we put 50 larvae inside, and the water's flowing down here. And then we wait half an hour that they distribute the small fish. And then we start here to reduce the discharge, and then it falls slowly dry, and with that we can work to look for the ramping rates. And the results showed that if it's below 0.1 centimeter per minute, the reduction of the flow of the water depths, there's still some kind of stranding risk, about 0 to 20%. If it's intermediate, it's already 50%, and if it's more than 1 centimeter per minute, it's very high. And if this occurs not only once, it occurs maybe 50, 100 times in the season that we have the larvae, because they live at the shoreline, it really It's not so easy, but what was really, or still I have not the best feeling, because if you look at the ends, we have only 18 cases, 18 observations with the big one, additional 20 with the smaller one, and still we have also cases where it was 10 meters the maximum distance which could fall dry, but in reality maybe it's 100 meters in some cases, some rare cases. But we also did some drifting experiments where we artificially, or we said there's one day or one morning that I could say, please, Marco, not you, Marco in our case, who is responsible for the power production. I want this discharge, I want this production, and he did it so, and we did it one where with a very fast increasing rate, and the second time with a slower one, with a decreased one. We pumped up the water here out, put the water through on a net here, through a net, and so we could count then later the box. What we found, I could show a lot of slides, but I think I'm now at the end. Everybody's at the end, me too. But if you have questions, you can ask me later. What we found, just very, very briefly, between 5 and 20 cubic meters per second, the shear stress is not enough that we see a drift. Between 20 and 40, then it's really, if it's very fast, then we see really a kind of catastrophic drift. And after between 40, and here in this case it was 50, we did also with 90, we didn't see it anymore. Then these insects which not went in time into the sediment, they have been removed and the others have been saved. So there's also a methodology to how to plan, or how to, if the moderator is leaving already, it's not a good time. It's almost my last slide. So there are different aspects, indicators which you can apply, just that you know if there's the need in present one. How I think a lot of indicators are very physically, they could be really also translated to present.
The microphone give up as well.
There's too many signs. So, final.
Because we are online, please.
O final, no caso, tem a vontade de aprofundar nossa experiência de aspectos de avaliação dos impactos e médias de comunicação para os ecossistemas aquáticos e terrestres, de variação artificial de fluxo de água, hydropique, processos participativos e, finalmente, as duas perspectivas de ecologia e de produção de energia. Eu estou dispor a vocês. E agradecimento pela minha equipe e pelo magnífico.
Excelente apresentação, Steffen. Agora vamos abrir para as perguntas.
You mentioned about the downstream migration, that to put fish upstream is a matter of money. In terms of technology, there is no constraint anymore. And we have this problem here in Brazil because fish used to go upstream to spawn, and then after they should come back to the nursery, to the feeding areas downstream, and our systems, transposition systems, do not make it available for fish to come back. What is the experience you have about the downstream migration there in Switzerland?
This is the other hot potato. There are some solutions we have. Maybe apresentação. So in our case, this is the only water intake where we talk about fish migration. All others are too steep, naturally not important. And even for this, you can discuss if it's necessary, because there are some steps, natural steps, before and below, below and above. What we installed here, where the water flows from the water intake, we installed a small tube going down. We also, to attract the fish, we put some metal, I don't know the word in English, neither in Portuguese, neither in German.
Fish gates or fish
No. It's like this. It's just like metal, but much bigger. That you see the water is flowing this direction, and here is the entrance to the tube, and we put a very big thing of metal, like a folia now. I don't know how you say it, to attract the fish that we can find. And we have not been. They didn't ask us until now to do monitoring, but we have just started with new hydrocams, and we have seen already fish going down. But I don't have any results. So this is working. In our case, also during flooding times, that occurs maybe 20 days per year or 30 days per year. This is completely open, so the fish can migrate downstream. And we found fish which have done this ride 3 times, 4 times. This is our case. Other cases where we have really big, there are existing bar wrecks, some ideas about that, also a little bit projects. I would say for streams and for the medium rivers, scale Switzerland, please. It's maybe working. For the big ones like the Aare or the Rhine, very, very cost intensive, and you never know what happens after the next flood. You need a barrack of maybe 100 or 200 meters. You need different entrances to the fish. With this barrack, you change the behavior of the fish, because the eddies are not attractive for the fish, so it doesn't go into the system. It just goes along the barrack, and then maybe it goes into a bypass down. But still, it's a hot potato.
Just complement. What are the size of the fish that go downstream? The juveniles or adults?
Both, depending on the fish species. I would say for salmon, we have already, I think, in the last 5 years, we have observed maybe 5 salmons at the beginning, at the entrance of Switzerland, at Basel. But we have the lake trout, or the brown trout, or the Thymanus. I don't know at the moment the name in English. And they also go down upstream for spanning, downstream afterwards. But you also have always a movement of the small fish going downstream. We have also the eel, which goes maybe whenever it goes. Yeah.
Yeah, I had a quick question. I noticed that the channels are pretty kind of like a plain bed channel, and I wondered whether they had explored changes in, like, if you had a lot of habitat complexity, a lot of depth and width variation, the fish wouldn't be experiencing as quickly the changes in discharge velocity and depth. If there were like places for them to hide from velocity and to hold, I mean, it wouldn't replace. It couldn't do away entirely with the changes in level, but it could be used in combination with those ramping and that thing.
It's a big ambition now. It's there are two aspects for the habitat loss. With a peaking discharge, it's meaningful to have a widening, of a wide river reach. But for the stranding, it's negative. What you could do in our case, what we have done, I could show due to time constraints. what we could do is we had reached with groins, and within the groins, or I can show for the others what are groins. This part, these are groins, and in between we put some in-stream measures like dead wood, like big boulders and things like that. And what was very surprisingly, we had the same fish density of the young fish, which is the biggest deficit in our reach, compared to another river, the Lütschine, which is hydrology, the hydrology and the morphology is natural. So that was really surprising. It's almost the same. So many questions.
I have more chocolate. Like, I have one doubt. Why is it difficult to approve our plans? Because the laws of the Switzerland, or because the laws of the Union Europe? What's difficult to approve the power plants?
From an energetic point,
Yeah.
it's in Switzerland, I would say 90 to 95% of the possible technical, economically reasonable capacity is already installed. So we don't have any possibility to increase. So this is our problem. And on the other hand, we don't want nuclear power plants anymore, no thermal power plants, and we have almost no chances to install wind. We would have wind, but due to landscape issues, it's also very difficult in Switzerland. So we only remains only photovoltaic. So is this the way the question, or you want to ask?
Yes. But there are specific laws in the Switzerland, or in Union Europe, it's a unique laws about the license. I don't know the name of this.
Is the licensing process hard because of
The concessions?
Switzerland laws or European Union laws?
No, in our case, we have only the Swiss law. We are not part of the European Union. So, but they are different in each country. Also in Europe, they have different rules, different how they get a new concession, how to find all these ecological measures. In Italy, for example, they have to. It's like everybody can account for a new concession for the next 30 years, can apply for it, and has to show about so-called Umweltgelder, money for the environment. In Austria, it's defined by the hydrology. In Germany, I don't know. And in our case, it's really to do, other topic. But in Switzerland, we are really looking at ecology, hydrology, and landscape issues, with some possibilities to interpret.
Steffen, if for those of you that really love mountains, you should spend some time hiking in Switzerland. It's incredible. What about the climate crisis? How is that looking ahead 50 years when you come to trade glaciers for lakes, essentially? You're storing water. Storing water and ice instead of. You're trying to store water in lakes instead of ice, which is, ice is very, very stable. It used to be, but now you're losing it. 50 years from now, what are you going to do?
Short, medium, or long reply. A medium of it. Yeah, I see. The question is a good question, and how you ask the question, you understand what's going on. Just one moment. Yeah. So as mentioned before, the glacier was 40, 50 years around here. Now it is here, and it will disappear within the next 50 years. There are two big glaciers. There will be some glacier left here and some left here. So first, the short answer would be our climate models say for us, the mean annual precipitation will be more or less the same in our region. But as you remember, what we are from an energetic point of view, what we are facing is this. And at the moment, what's going on, we have, maybe this is all to explain quickly. Usually, in winter, we get the precipitation snow at this height. Then in April, May, it starts the snow melt. Until June, the snow is melted. Then the glacier melt initiates June, July, August, September. And then the inflow into the lake, the reservoir is getting very low again. So the glaciers actually, or how we manage our lake, usually in May, it's more or less empty. Then we fill it quite quickly, June, July, have it at the top, and the glacier is still working as additional reservoir. And then in October and November, depending on the prices, we start to empty it to produce, to stabilize the net here. So when the glaciers are disappeared, we will have a very high inflow in May, June, and then nothing else. Maybe some rainy events, July, August, September, but not constant glacier melt. So this is, from this point of view, or from this aspect, it's very meaningful to build this, to increase, enlarge our lakes. Medium, okay?
Pessoal, acho que devido ao horário, a gente está encerrando, pode começar com efectos. Gostaria de agradecer vocês, tá? Novamente.
Obrigado.
Thank you for the chocolate.
That was the best of my presentation, I know.
Maravilha, foi ótimo. Muito obrigado.
Obrigado pelo convite.
Pessoal, a gente está caminhando para o fechamento, mas eu queria pedir, antes da gente passar para a última etapa, eu queria pedir uma salva de palmas para os meninos que trabalharam tanto na organização, antes, durante. Vocês viram o tempo todo, os meninos correm para cá, correm para lá, e chega cedo, e vai, e pega carona, e puxa, organiza coffee break, faz isso aqui. Muito obrigado, foi fantástico, assim.
Em especial pela beleza do antigo.
Tem presente.
Bob, Luisa, we were thanking the students that they worked hard during the workshop, before the workshop, during the workshop, and the end workshop. So that was our thank you for that. E para a última etapa, então, eu passo a palavra para o time da homenagem.
Olá, pessoal!
Mas vocês vão falar alguma coisa antes? Don't try. Eu vou falar inglês.
É uma surpresa para vocês, para a gente não sabe exatamente o que estamos fazendo aqui, mas a gente vai, eu não vou falar inglês. Acho que não precisa não, a gente vai só dizer qualquer coisa, quebra o galho aqui. A gente queria fazer uma pequena, eu não sei como que eu vou chamar isso, mas tem duas pessoas aqui muito importantes para a gente chegar até o segundo workshop, né? Porque desde, sei lá, há alguns anos atrás, muitos, 20, talvez no século passado, eu já estava aqui, acredito, eles estiveram com a gente e hoje tudo que é feito com todas as pessoas que foram convidadas, palestrantes, nós que estamos aqui, muitos, né, de vocês, e tiveram influência fundamental, né, do trabalho, do IBI, claro. Então, a gente queria fazer, nós montamos uma pequena historinha para contar, que o Andinho vai passar.
Andinho.
Tem que ter som nesse trem, né?
Thank you. Thank you. Thank you very much. Thanks, Paul. Cheers. Very much indeed.
Obrigado, Giro.
Por isso que eu te arranquei aquelas informações.
Não, você vai mandar para eles.
Aí a gente manda, né?
Tem que mandar para eles. Tem que ser um link.
Põe no YouTube do laboratório.
Pessoal, todo mundo está com a camiseta azul, vamos juntar, fazer uma foto. É o pessoal do projeto. Ah, não, tudo bem, do projeto.
Vamos conhecer, todo mundo que é da equipe anfitriã. Vamos juntar para tirar uma foto. E depois te junta.
Não, brincadeira. Tira uma primeiro a turma que fez a homenagem, você para cá e as meninas. Phil, well, can you go ahead and just take a picture of you with Cacá, Marcos, and the...
Before the moment is done, I want to say that it's you guys that did all this. We're kind of a little catalyst with some ideas, and we are, every day we're impressed with all the things that you've done. But I want to follow up what Phil said. The reason that we come here is you, and all of you. This connectivity cannot just stop with some North Americans. You have to continue through South America, and that's why we're trying to get you to come to meetings in North America or Europe or wherever. It doesn't matter. You have a lot to give. A lot of you are shy to speak English. Don't be shy. Try it, just like we try to speak Portuguese. Don't half at us, it's okay. But try to tell the world what Brazil has to offer. It's an incredible country, just incredible.
Thank you.
Pessoal, agora o Marcos está pedindo quem faz parte da equipe do projeto para vir aqui para tirar uma foto. Só quem tiver com a registração.
Azul, amarela, preta.
O aceite vendido. Não
tem problema. Tem que arriscar.
A Julia vai tirar para gente.
Vamos juntar todo mundo. A expressão foi mal. Esse camiseta azul e o resto. Isso. Não, tira em pé também, hein?
Olha a barriga, moça.
Umas três.
Deitado em pé.
Tem que tirar em pé também, porque pode ser longe.
Instagramável. Aí.
Só na cidade gosta, né?
Agora todo mundo.
Ele está aqui chateado. Tem Instagram, não tem essa dúvida.
Tem Instagram.
Agora todo mundo, cara. Pode mais falar.
Anônimo. Aquela pode.
Viu?
Isso. Que é isso, Cacazinho? Lá no Rio Grande do Sul.
Ô, Felipe. Ele quer falar para
cry. And so it was a great experience, and I do appreciate and do thank you all for coming, for accepting the invitation, for kind coming, for sharing all the knowledge. And also I will ask Felipe to, on behalf of the Eletrobras, to say thank you for all the team, please.
Thank you, Marcos. Obrigado a todos. Eu vou falar em português, mas vou falar curtinho também. Acho que a gente já conversou bastante ao longo desses dias, mas em nome da Eletrobras eu queria agradecer a presença de todos aqui que tiveram ao longo desses 2 dias, com todas as suas tarefas e tudo mais. Agradecer quem veio de diversos cantos do Brasil, de outros cantos do mundo, para estar presente aqui nesses 2 dias, a gente trocar a experiência. A empresa é importante porque foi uma iniciativa que começou lá atrás com uma conversa de meia dúzia de pessoas tentando desenvolver um projeto que fizesse sentido para a empresa e que trouxesse melhores práticas ambientais. Foi uma corrida doida, como eu falei, porque a gente contou a história rapidamente aqui, de repente falou tem que ser agora, e aí a gente fez acontecer e em 1 mês, mais ou menos, a gente tinha fechado o contrato do projeto. O projeto hoje está chegando no seu 2º ano, né? 22 de dezembro, aniversário dele. E a gente, como eu disse, o projeto vem andando muito bem, os resultados estão aparecendo, os resultados estão acontecendo. Esse evento era fundamental para a gente ter, no primeiro ano, obviamente, a gente praticamente só tinha a coleta de dados, a gente ainda não tinha algo palpável para poder começar a conversar, a discutir, a trocar ideia, a ter percepções e começar a pensar em ações futuras que a gente possa fazer para melhorar a bacia como um todo e, consequentemente, trazer benefícios também para a empresa, porque esse projeto é uma via de mão dupla, né? Então, a ideia é que a gente olhe para o aspecto ambiental, mas que traga benefícios para a empresa também. Então, em nome da Eletrobras, eu queria agradecer a todo mundo que pôde estar presente, principalmente a equipe que, desde o início, foi no campo e sentou no laboratório e faz as análises, porque, enfim, sem vocês, no campo, na análise, no relatório, o projeto não ia acontecer. Ninguém ia estar aqui hoje trocando essa ideia e conversando essas coisas. Então, muito obrigado a todos em nome da Eletrobras, e a gente já pode pensar em revê-los agora, quem sabe, daqui a 1 ano, com o relatório final para fazer a apresentação do projeto novamente.
Lá no Rio.
Pode ser lá no Rio.
Tiago, você quer?
Só uma frase final, por favor.
Só para terminar uma frase de coach. Nós na Eletrobras fazemos eletricidade, mas a verdadeira energia... Obrigado.
Gisele and Juliana made this nice film. No, it's just a great. When I begin thinking about making the IBI here in Las Vegas, and I didn't yet, I talked to Jim Carr before talking to Bob. And Jim Carr changed some emails with me, and I told him that Bob and Phil will come to join us. And there is a very interesting sentence that I have in my email, 2 computers before this, but I will find it. And he said, quoted, you cannot go wrong with Bob. Jim Carr, 2000 and something.
I have a hard time talking when I'm almost crying. So,
Thank you very much, you guys. I maybe in a sentence, I'll say, you guys can make field work and conferences into a party. There's no one like Brazilians. And like Bob and I are in the United States all the time. I don't think we ever are moved by a group of people like you. So thank you so much.
Pessoal, então, bom feriado a todos. Descansem, respirem, né, e aproveitem a vida. A vida é uma só. Obrigado.